Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at simplifying identities. This is what I gave to my students earlier in class, and this is what we were planning on working on before we ran out of time. And I figured that there might be some people who would want to go through this ahead of time as opposed to trying to do it all at once in class. So the whole idea behind this is that we have a whole bunch of fundamental identities. These were the identities that we saw just the other day. And if you've been following along with me, then you are probably well aware that these were on section 5.1 from our textbook, and I'm going to put them up right now. These identities are what we are going to be using in this activity and in our practice. Now, I would like to just remind people that we started talking about even functions and odd functions, and we were talking about arcs, and I had mentioned that the arctangent was an odd function, and that the arcsine was an odd function, and that the arccotangent was neither, and that the arc cosine was neither. And I asked you to think about the arc cosine, the arc cosecant and the arc secant. I took the liberty of drawing down the arc cosecant so that you can see that, yes, indeed, the arc cosecant is odd, whereas the arc secant is not odd or even. So it is also neither. This is because of the asymptotes placement, and you'll notice we do not have a reflection through the y-axis, and we do not have a reflection in the origin, as it would be forced to come down here. So just a follow-up of what I was doing just the other day, and what I'd ask people to consider. Now, when we are trying to simplify, sometimes one of the best things that you can do is by replacing any tangent or cotangent with sine and cosine equivalent from those identities. And if you do so, these start to simplify. So you'll notice cotangent is cosine of x divided by sine x, and by direct substitution, I can replace the cotangent of x with it, and then multiply by the sine of x. Since we have the sine of x in both cases, they cancel out, and my answer is the cosine of x. Notice when we're working with the secant, I want to replace my secant with the less complex cosine. So I'm always trying to put things into sine and cosine if I can, and then go from there. Now you'll notice sine multiplied by 1 over cosine is sine of x over cosine of x, and we know that this is our ratio or our fractional identity for tangent. As a result, the answer is tangent, whereas the first one was cosine of x. Notice the second one, secant over tangent. You're always going to want to break complex things up, so I'm going to call this secant of x. Excuse me, I called it the sine. So I'm going to have the secant of x times 1 over the tangent of x. And I'm now going to call this 1 over cosine of x, and this is going to be the cotangent of x. And then I have 1 over cosine of x times cosine of x over sine of x, and the cosines cancel, leaving me with 1 over sine of x, which we're going to call the cosecant of x. Here, we're going to break this up again. We now have a product of 3 pieces. So I have the cosine of x times the cosecant of x times 1 over the cotangent of x. I know that the cosecant of x can be replaced by 1 over sine. And I know that the cotangent of x is simply the tangent of x. I'm now going to finish by simplifying this. So I have cosine of x, sine of x, times, now I replace the tangent with sine of x over cosine of x. And my answer is 1. Going to E. This is our Pythagorean identity giving me the cosine squared of x. So I have the cosine squared of x, and I have 1 over sine squared of x, and frankly, I'm going to go ahead and leave it in the denominator, since it's already a sine squared of x in terms of sine, and I know that this has to be parenthesis. I can factor out that square, so I have cosine of x over sine of x, and that's really the cotangent of x, the quantity squared. Okay. Now, once again, sometimes they'll ask us to put it into terms of a specific function, like into terms of sine or into terms of cosine, possibly even cosecant, secant, tangent, or cotangent. So regardless of what we do get here, if we haven't done what they've asked, we have to keep going. Here, we're now going to look at this as our cosine squared of x from the Pythagorean identity. I'm looking at 1 over cotan squared of x. This is going to give me cosine squared of x times the tangent squared of x. And I'm now going to replace the tangent squared of x. So cosine squared x now multiplied by sine squared x over cosine squared x. And the cosine squared x's will cancel, leaving me with sine squared x. Now, this is currently in terms of sine. If they had said to put it in terms of cosine, I would now use my 1 minus cosine squared x equals sine x in order to do something different. G. Sine x times the cosecant of x divided by the cotangent of x. Once again, let's break it up. Sine of x, cosecant of x, cotangent 1 over the cotangent of x. Watch out there. Almost made a little mistake. We didn't want that. Now, we're now going to simplify this. Now, we've already seen certain things like the sine times the secant of x, which simply gave me sine times 1 over cosine. Here, we're going to expect that this sine of x times the cosecant of x should actually cancel and be 1, since this piece is 1 over sine x. This is really the tangent of x, and these will cancel, leaving me with just the tangent of x. Now, if they tell me to put it in terms of sine and cosine, I would go one step further and call it the sine of x divided by the cosine of x. But because they didn't, I'm going to leave it as the tangent of x. Once again, why make it simpler if we don't have to? Cosine of x times divided by the cosecant. So cosine of x times 1 over the secant of x. So cosine of x times cosine of x, and we end up getting cosine squared x. This is going to be my answer, and if they wanted me to put it into some other units, I would do so. Next, we have the tangent of x times the cosecant of x times the cosine of x. I'm going to just as easily call the tangent of x the sine of x over the cosine of x times the cosecant of x, which is 1 over the sine of x, times the cosine of x. Notice the cosines are going to cancel, the sines are going to cancel. This is going to equal 1. J. Cosine squared of x divided by 1 minus the sine of x. Start by breaking it up just like we did before. So I'm going to call this the cosine squared of x times 1 over 1 minus sine of x. Now, when I do this, I can replace the cosine of x with 1 minus sine squared x. Notice it's a difference of squares. And I'm going to have to break this up into its product. 1 plus the sine of x times 1 minus the sine of x times 1 over 1 minus the sine of x. 1 minus the sine of x is canceled, and I'm left with 1 plus sine of x as my answer. Next, we move into this concept of solving, or simplifying things so that we can solve. Notice that sine of theta is a common factor. That will allow me to factor out the sine of theta, leaving me with cosine squared theta minus 1. Be careful, it's not written correctly. If I want to write it as sine squared x, it has to be 1 minus cosine squared x, which will force me to bring out the negative. This will then allow me to work with 1 minus cosine squared theta, and I can now substitute. Minus sine theta, and I would end up with sine squared theta. Now, regardless of what we're trying to do, we're still working with identities. Now, the question simply asked me to factor it. That's its factoring. I suppose I could factor it a little bit further and break that down. So I have another option, sine of theta times cosine theta plus 1 times cosine of theta minus 1. So notice, here's a possibility, here's a possibility. And I like this one as well down here. Negative sine times sine squared. And I would end up getting a simplified negative sine cubed. So all I'm trying to do is show you how we can use factoring and the use of our identities to simplify things into terms of sine, possibly into terms of cosine, possibly into terms of tangent, or whatever is asked. So if all I'm trying to do is factor, I can see there's a cosecant. So the cosecant of theta is coming outside, leaving me with the cosine squared of theta minus 1. Once again, we know this is 1 over sine. This is not correct if we are trying to put it into terms of sine, and would force us to factor out a negative. So we would have negative 1 over the sine of theta, and I would then have 1 minus cosine squared theta, and this would then give me 1 over sine theta, and it's a negative, times sine squared of theta, and you'll notice this is really negative sine of theta. So that's what it would be if I were trying to put it in terms of sine. If I'm factoring it, I still have to keep going. Cosecant of theta times cosine theta plus 1 times cosine of theta minus 1. And then this would be my factoring, which is what was asked. Notice, here factoring again. I can call this secant of theta plus 1, secant of theta minus 1. Once again, all they were asking me to do was factor. I could always continue to manipulate this and put it into terms of cosine. To do that, I would replace the secant of theta with 1 over cosine and get a common denominator. Same with the secant of theta here and get 1 over cosine minus 1. I would get the common denominator, and things can possibly cancel or create new identities. When we're looking at a 4 tangent squared theta plus tangent theta minus 3, sometimes it's useful to use a dummy variable, and I'm going to say u equals the tangent of theta. When I do my substitution, I get 4u squared plus u minus 3, and I can now factor this. Let's just call it 2u. You'll notice I'm into my process, just trying to get things set up. Looks like I need a 4, so I'm going to put a 4 here, and a u minus 1. We know it's got a positive and a negative. And now I have 4u, 3u. But notice this is giving me a positive, a negative u. So I'm going to change my location of the negative and the positive. And now I'm going to go back and resubstitute the tangent with our u variable. We get tangent of theta plus 1 times 4 tangent of theta minus 3. And now it's factored. So this is just the first side of the work that I was asking you to do. And on Sunday, I will probably make the second of this, where we will go to the second side. I hope this has helped you. I hope this makes more sense. Please remember, you have to know those fundamental identities. Otherwise, the verifying of identities and the simplifying of identities, not to mention the factoring in order to solve, are going to crumble at our feet. So please, study your identities. Make sure you know your ratios, because it's not long before we're going to have to solve these. And it's with the ratios that we're going to solve them. All right, Hornets. I hope this has helped. If you found this to be a useful video, please remember to click like, and I hope you have a fantastic weekend and evening. Take care, be well, and good night. Cheers.